Chapter 8, Way to Go, Mastering Specific Gravity. It's time for a little bit of math, but that's okay. A little bit of math never killed us. In fact, this math is actually like a secret magic weapon to be able to determine, like, pretty specifically and definitely what something is. It can be the key. Essentially, through this little experiment, we're figuring out the density of the rock. And then in our handy dandy manual, it will give us either like a really small or larger range, and we want to find a mineral that has the specific gravity in that same range. Now, this isn't so like particular with rocks. This is more of a mineral thing, but it can help us with rocks as well. Now, on the mineral side, it will tell us exactly what the specific gravity is in these details here. And we want to try to match that to what we figure out in our testing. With rock listings, though, we're not so much given a specific gravity, but it gives you the components of it. And so it helps you with your investigation of what components are in the rock. Sometimes there's big enough crystals or chunks, you can get that off and like break it off and measure the specific gravity of one of those chunks and help you narrow down what the constituent components of the rocks are if the crystal structure is large enough. Also, when it comes to specific gravity, it can help you tell the density of a rock, and so that can also help you in the identification. That's all specific gravity is. It's testing the density of a rock and putting a number to it on a scale. All right, let's do some specific gravity tests. Turn on your scale. Weigh your glass cylinder. Tear the unit out, or zero the unit out. Now place each specimen in the container and weigh them both together. This is your dry weight. If you want to be very precise, you can weigh your piece of wire and your specimen together to get a more accurate weight. Because specific gravity is a range, a small piece of wire, thread, or fishing line, if you don't weigh it, usually won't throw off your calculations enough for the specific gravity to vary enough for it to not be accurate. The piece of wire I'm using weighs 0.9 of a gram, and I will be suspending it in the water, and so not all of that 0.9 of a gram will actually be impacting the water, more like 0.6 or 0.7. Then you document the dry weight on your handy dandy worksheet, or since I'm doing multiple specimens, I'm using a scratch piece of paper. Now we add enough distilled water, if we're being very picky, to the cylinder, and we zero out or tear this again. This brings it to a 0. Submerge your specimen without touching the sides or the bottom, and note that weight. Okay, we're fully submerged. I have an 8.2. 2.7. 6.7. And then we document those weights. Now we take the dry weight and divide it by the wet weight, and that is our specific gravity. And then we document it on our handy dandy worksheets or our homemade handy dandy worksheets. I happen to know what each of these are, so let's see if the book lines up with the specimen. The first one is opal. Well, looky there. Opal is a 2 to a 2.2. What did we have? 2.36. Nailed it. Topaz. Specific gravity 3.4 to 3.6. 3.4. We did it. All right, and last one, garnet group, almandine. 3.56 to 4.32. And how did we do? 3.925. Woohoo! Final thoughts. If I didn't make this clear enough, always tear or zero out your scale anytime you change anything. So when you add the glass jar, 0. When you add the specimen to the glass jar, weigh it, take the specimen out, 0. Add water to the specimen, 0. I wasn't super clear in the book, it's in there in the tips, but it's not in the instructions. Once again, 5 editors missed it, but still, it is in there. Just make sure you're always, when you add a new component to that glass jar, tear, zero that out. As you noticed, we were well within the range, even though I didn't weigh my dangling structure of copper. However, if you get super sciencey about it, scientists will weigh that amount of copper and do the math and all that kind of stuff. But we're looking for a range. So if it's just on the edge, then maybe weigh whatever you're dangling it with, or change what you're dangling it with to something lighter. But as you can see, we were in the clear. Speaking of dangling, when you do put your specimen in the water, make sure it's fully submerged and not touching the sides, and that you're not touching the cylinder either. If you really want to get super duper accurate, you can use distilled water, but as you can see, you were pretty darn close without it. So congrats, that's it. You have learned how to do the magic math. It's the difference between garnet and opal. Both orange, both gemstones, if they're cut, how do you tell? Well, this is exactly how you tell. Oh, and if you're looking for my cool book thingy and that worksheet, link in the bio. Thanks for joining me. See you for number 9.